So we've had torrential rain for the last couple weeks, but it's Oregon, so what do you expect? But the weather's a little break in the weather right now. I figured I'd show you guys a little bit of what's been going on. So you can see lots happened since the last time. I have the upper cabin framed in, the gusset plates on the corners, all that's welded in, and this is all going to be enclosed space when it's done. So there'll be sides all the way around wrapping this, and there's going to be a mid-level deck coming out from the middle there, and that'll shoot out, and then coming up there's going to be an octagon bar top right in there, so that still needs to be framed in. But up there near the top is where the ship steering wheel is going to be, and that's going to put the captain's feet 9 feet off the ground, so it's going to be a pretty good view up there. We got all this triangular truss tack welded in, and this is all left over from engineering competition that I was involved in a few years ago, and it was going to be recycled or reused, and I opted to reuse it in the pirate ship. Some of this material, this is cut-offs from a friend's shop, and some of the material is over-engineered for the load it's going to carry, but it was cheaper to get cut-offs than it was to buy brand new material. So that explains some of the over-engineering in here. Also got the ship's wheel off the ground. Now this was on a test frame for the last year almost, and it's now sitting on this roller frame, and these rollers are going to allow to spin the wheel, and actually for the first time ever the wheel spun all the way around, and it's a tight fit. When I designed this cog, I designed it with pretty much zero clearance, and then I wanted to come through, and you can see the spots where it's wearing, and I want to hand sand those down so that I can minimize the amount of backlash. If I designed it with a little bit of slop into it, I would be stuck with that level of slop, but this way I can minimize that and get a pretty tight fit on that cog. Did have a bit of a setback. If you remember from the last video, there was the spider coupler, which looks something like that, and it mounts to this shaft here that goes through to the cog and the steel plate in the cog. Now what happened, this part held fine. This is the part I machined, but on the gearbox, there's a gearbox there, you can see that brake, and this is the piece that broke off. And if you look at that, and you see like really tight crystalline structure of metal like that, looks like lava rock. That's just really, really brittle metal, and it shouldn't have broken like that. This piece, granted it wasn't the most expensive coupler I could have bought, it was rated for 23 horsepower, and 23 horsepower works out to be over 12,000 foot-pounds of torque on here. And when I broke it, I figured I was putting roughly 700 foot-pounds of torque. So huge difference between 12,000 and 700. But one of the things it did do is I kind of lost my confidence in this whole setup. If something breaks out on the playa like this, I'm not going to be able to go get another one, and I don't want to have to carry extra parts like this. Also, I'm a little nervous with the gearbox, and you know, something breaks in there, same thing. And I like seeing how stuff works and seeing how and demonstrating those mechanical principles. So what I'd like to do now, and the change in the design, is I have these bolts, and they bolt right through to the drive plate, that plate in the middle that turns the cog. I'd like to bolt a sprocket onto here, and they make these weld-on sprockets, and I think I can find one that'll fit and modify it. And I already happen to have some chain here, and this looks like your normal bicycle chain, but put my thumb next to one of these links, you can get an idea. That's a bit bigger than your normal bicycle chain. So hopefully I can reuse that. I do have this little sprocket, and I think I can modify this for a motor. And so that there, and the chain will drive up through here, and somewhere in this mid-level area, I've kind of got this nice little cavity kind of hole, right in there. I'd like to mount a hydraulic motor. And one of the nice things with a hydraulic motor is I can run a second hydraulic motor right off the same line to the rear axle. Now, rear axle will probably be a heavy truck, like a 350 pickup truck, and right off the differential from there I can put a second hydraulic motor, and they can be running off the same line as the chain drive here. And what that's going to do is, regardless of the gear ratios, it's going to have the same load of hydraulic fluid through that line, and it's going to spin both hydraulic motors at different speeds, but it's going to load balance the force going to them, so it kind of acts as a differential. It's going to go to path of least resistance, whichever drive is easier. It's going to split it up, but the rear wheels and the 10-foot diameter wheel will be going the same speed on the ground. So that's the nice thing about doing that setup. It's going to add a lot more dependability on the drive system, and not relying on a small hydraulic motor or electric motor here. The hydraulic pump and the motor that drives the pump can be enclosed in the back, and dust can be kept out. So it's going to be a bit more robust system. So this is about my longest video, so I'm going to stop it here, but give you guys an idea of what's been going on. So thanks for watching.